Second revisions in tendon repair. Inevitable or preventable? Your call. Tendon injuries, particularly rotator cuff tears, affect more than 1/4 of the global population over the age of 50, leading to pain and functional loss. The high recurrence rates and frequent reoperations associated with established techniques are major contributors to repair failure, highlighting the need for safer biomechanical harmonized alternatives such as Ziptek's BioLock system. Introducing ZipE, the only product with an innovative system that incorporates biowasher technology. Inspired by validated principles of mechanical engineering, Ziptek improves load distribution and repair stability by integrating locking washer-type systems into fixation. This design expands the contact surface, generates controlled compressive forces that increase resistance to rip-through, supports faster functional recovery, and minimizes the risk of suture loop-induced tearing. BioLock system. This button technology incorporates a self-locking mechanism designed to slide along a pre-configured suture with progressive safety locks acting like a surgical zip tie to ensure controlled fixation. Its unidirectional design reduces the risk of tendon strangulation by providing stable load distribution, securing the tissue firmly yet gently, and promoting remodeling. Bone preservation. Unlike conventional techniques, this double-row approach requires only 2 perforations, enabling comprehensive remodeling of the tendon-to-bone interface while preserving superior integrity of bone density, architecture, and substrate quality. Reconstructive biomechanics. Ziptek introduces unique controlled compressive forces perpendicular to the repair interface, enhancing structural strength and optimizing tendon stability. This temporary load-sharing mechanism enables the repaired tissue to gradually resume functional loading, resulting in a safe, durable construct that remodels naturally into stronger and more elastic tissue. The system is composed of an anchor preloaded with high-strength sutures, mounted on an ergonomic driver, and ready for immediate use in surgery. Once deployed, the anchor is securely positioned in the bone, and the suture is passed through the tendon to enable controlled sliding of the ZipE button along its path. Thanks to its bioresorbable design, the button advances with minimal resistance and without the possibility of backtracking, activating a self-locking mechanism that maintains constant tension and compresses the tendon firmly against the bone, thereby reducing the risk of re-tear and the need for revision surgery. With time, the bioresorbable implant undergoes remodeling, which promotes biological integration, restores functional strength, and increases the long-term durability of the repair. Graft placement with the ZipE system eliminates the risk of suture entanglement. The technology allows the graft to be introduced arthroscopically in a guided fashion, sliding it down the suture with the ZipE driver without the need for a cannula that could damage the graft. While posterior first orientation generally offers a more straightforward approach to tendon repair, providing better visualization of the footprint and natural retraction patterns, this training presentation begins anteriorly to illustrate a worst-case scenario and provide a clearer, step-by-step demonstration for educational purposes. Each procedure presents unique challenges, and surgeons are free to choose the sequence and orientation that best suit their clinical judgment and operative strategy. Arthroscopic rotator cuff repairs generally performed using 3 portals: a posterior portal for visualization, and lateral and anterior portals for instrumentation. Each portal should be fitted with cannulas with an internal diameter of no less than 8.4 millimeters incision. A minimal incision is made as accessory portal over the zone to be constructed or at the edge of the acromion for supraspinatus repair that will be used for the insertion of the anchor, as well as for insertion of the button and graft when used. This approach minimizes soft tissue trauma and facilitates precise handling. Selecting the ZipE button's configuration. For small or moderate tears, a horizontal or vertical construct using 2 buttons may be adequate. For larger or complex tears, a horizontal or vertical double parallel configuration using 4 buttons may be considered. The driver is best manipulated through the accessory incision, while the suture passer is recommended for use through portals. Preparing the insertion footprint. Visualize the surgical footprint considering the extent of the tendon damage and planned fixation. For the vertical double row technique on a supraspinatus tendon, start by carefully preparing the tendon and its footprint. The bone surface should be gently debrided to stimulate healing, avoiding excessive decortication that compromises bone strength. Anterior fixation. Preparation of the anchor. Using a ZipE repair kit, release the nitinol wire from the driver by pulling it straight down from under the silicone O-ring without removing the suture or any other component of the system, and pull the sutures tight behind the O-ring to ensure the anchor is properly seated on the driver. Localizing the insertion site. Use a spinal needle introduced through the planned anterolateral portal to identify the insertion site, centering it between the medial and lateral positions of the anterior row. Creating the pilot hole. Remove the needle and insert the punch through the skin incision, and then create a pilot hole at the same point. Use an arthroscopic razor to remove any sharp edges around the created hole. Anchor insertion. Confirm that the anchor is firmly seated on the driver by gently pulling the suture ends. Insert the anchor through the anterolateral incision and advance it to the first laser depth mark, orienting the driver grooves from medial to lateral to align with the expected button position on the tendons. Removing the driver. Release both suture ends from the silicone O-ring by pulling straight down and toward the tip. Remove the driver by applying a gentle downward tap with a surgical mallet. Warning: avoid circular or levering motions, as these can compromise anchor stability. Always release the sutures before removing the driver. Removing the driver with sutures still engaged in the O-ring can weaken the repair. Verifying suture mobility. Pull each suture limb individually to confirm smooth sliding through the anchor. This maneuver also clears bone debris and prevents obstruction. Warning: never pull both limbs simultaneously, as this can alter the progressive locking mechanism or compromise the anchor's hold. Symmetry in the number of progressive safety locks on each side of the anchor is recommended to be maintained throughout the surgery. Securing the suture limbs. Ask an assistant to hold the lateral suture limb securely or fix it to a stable point in the surgical field. This prevents accidental displacement during manipulation of the medial limb. Repair variants. If the procedure requires an interpositional graft, pass the medial suture through the graft outside the patient using the suture passer of your choice. Warning: avoid pulling on the medial suture limb completely until the lateral limb is firmly secured, as this may result in unwanted suture extraction. Using the ZipE driver, slide the graft along the medial suture until it is inserted through the skin incision, continuing to the subacromial space. No graft. After completing previous step, or if no graft is needed, retrieve the medial suture through the lateral portal using arthroscopic grasper or another suitable instrument. Load the suture into the passer, insert it through the lateral port and pass it through the tendon at the medial portion of the tear. Retrieve the suture through the anterolateral incision with the tool of your choice. Confirm there are no obstacles by sliding the driver along the medial suture until the tissue is gently compressed against the bone. Warning: avoid pulling on the suture at this stage to prevent accidental displacement. If onlay graft is required, pass the medial suture through the graft at the point intended to cover the medi-AL position of the repair. Using the ZipE driver, slide the graft along the medial suture until it is positioned over the torn tendon. Placement of the medial button. Position the nitinol wire through the center of the first button in preparation for placement. Pass 1 or 2 inches of the medial suture through the nitinol wire loop and fold the suture back on itself. Grasp the opposite end of the nitinol wire with a smooth needle holder or hemostat. Wrap the wire around the tip of the instrument by rotating it upward. The tooling will act as a holder, providing the necessary support to transfer the button onto the suture. Hold the needle holder firmly as a support while advance the first button onto the suture, with a gentle, steady pull along the nitinol wire until it passes completely onto the suture. Remove the medial suture from the nitinol wire and insert it into the driver until the button is fully seated at the driver tip. Warning: if the button is not properly seated into the driver, it may be difficult or impossible to slide it along the suture. Using the driver, slide the button along the medial suture, sequentially engaging each progressive safety lock until it reaches the repair site without pulling the suture. Warning: hold the medial suture firmly without pulling during this step. Since the lateral end remains free, there is a risk of accidental disengagement. When making contact with the tissue, the button generates an approximation of the tissue to the bone imprint, allowing precise prepositioning of the repair before final tensioning. Verify proper seating of the button by gently pulling the lateral suture end. Confirm that no folds or irregular tissue interpositions remain. If necessary, use a curved probe to reposition the tendon or graft into the optimal anatomical alignment. Suture placement and lateral button. For the lateral repair, follow the same overall sequence of steps as for the medial button, keeping in mind that the steps to be performed with the driver will be through the anterolateral incision and those of the suture passer through the lateral portal throughout the surgery. Pull the lateral end of the suture out of the lateral portal, load the suture on the suture passer, insert it through the lateral port and suture the tendon along with the graft if existing through the lateral portion of the tear. Retrieve the suture through the anterolateral incision. Advance the driver along the lateral suture to confirm smooth sliding and to ensure there are no obstacles. This maneuver helps settle the tendon or graft against the bone footprint. Remove the driver and load the second button into the lateral suture, following the same procedure described for medial button and guiding it until it is fully secured in the repair. Once in position, tighten the suture to engage the self-locking mechanism of both buttons. Using an arthroscopic cutter, cut the suture after the second progressive safety locks from repair. This biotechnology compresses the tendon and graft, if used, evenly against the bone, creating a broad, strong, and homogeneous contact surface that promotes stable healing and optimal tissue remodeling.